there's no further business, then I'm going to go ahead and turn it over to Vicky. Okay. Who's going to talk to us today? Long time. She was here since the first Pyninsula.
Yeah, I think I've only missed maybe one.
Exactly. But it takes time to build up courage to give a talk, you know?
Yeah.
And we're very thankful for her contribution tonight.
Yeah.
Looking forward to it.
Okay. Hopefully I'm not blocked. Okay. Some of you from the back may not be able to see this, so you can go to my GitHub, which is Tuite, Tuite, and Ipython Box tricks, and you can follow along with either the notebook or the slides. So I'm Vicky Tuite. I've been doing Python since 2004 and probably Python version 2.4. But my day job is usually embedded system programming in C, which sometimes when I want to do something in C, I think, gee, I wish it's so much easier to do this stuff in Python. Why isn't it here for me? This is Ipython Box, which is a kind of a cool teaching tool for beginners, particularly kids. I think kids, if you want to teach a 6th grader programming, they might not really want to do text processing or math problems. So here they can make pretty colors and pretty blocks and even animation. So this is a library that only runs on Jupyter Notebook, as far as I know. I'm not going to go too much into Jupyter Notebook, but Jupyter Notebook is a thing that runs in a browser, and it has different types of cells. It has code execution cells. Here's the bottom one, and it has documentation cells, which are making it, you can make big but ugly text. That's why, for this talk, I converted the notebook into slides, but it's really just one giant HTML thing I have to scroll. So Jupyter, probably the hardest part of this is to get Jupyter Notebook installed. And for that, I recommend a distribution like Anaconda or Nthought Canopy. And these distributions give you Python and over 100 other packages that are used for scientific programming and data sciences, but not Ipython Box, of course. So for that, you have to install it using pip. But one of the cool things about Ipython Notebook is that, or Jupyter Notebook, is that you could just do shell commands from the notebook. So that's what this exclamation point executable syntax is, and then you get your pip command. So the Ipython blocks really only have two main objects, a grid and a block. A grid has width and height and cell size, and we're initializing it to be 15 across, 8 down, and a fill color. So the blocks are RGB format. So if you're not familiar with RGB, RGB is a tuple basically of 0 to 255 for each of the red, blue, and green color channels. So if you have a tuple of 0, 0, 0, it's going to be black. If you have a tuple of 255, 255, 255, it's going to be white. And if you have 255 in the red channel, 0, 0, it'll be red. So if you do Ipython blocks for 5 minutes, you'll get RGB pretty quickly. Grid is iterable, so we build a grid, and then we just go for blocking grid. And in this particular one, we're just checking the block attribute is the block's column 3, and if it is, we're just going to set the green attribute to the max. And when we do that, we end up with a green column on this kind of navy colored thing. Now, if this was a real notebook and not this slide thing, I would be clicking in this part here and either doing a command hotkey thing, or they're up up at the top, there's a little play button to execute cells one at a time. That's kind of how Jupyter Notebook works. The next thing to know about Jupyter Notebook is that variables are retained from cell to cell. So here, we're still using the same grid, but we're going to start with a counter, and we're going to go through the grid again, and every 7th cell, we're going to set the red attribute to 200. So when we do that, we get these reddish diagonal stripes. So I wanted to do some fading, and so basically I did, made a grid and tried to assign the block to its attribute -13, and it didn't change. And I actually still don't know why, but I think it has to do with something with lazy execution. And so you can tell me afterwards if you actually know the answer to this. But we can do some debugging type things anyway. So let's put a print statement. Let's look at the blocks. And we'll look at the row, the column, the red. Maybe the red really is changing, but I just can't see it for some reason. But no, the red color hasn't changed a bit. And you can see when you iterate through the grid, we start with row 0, column 0, row 0, column 1. And so it goes across, 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 across. So I just added another variable, and when I change the variable and do the assignment, assignment to block.red component, it does, the color does change the way I expected it to. Okay, sometimes in Python, when you don't have all the documentation available, and I'm not super impressed with the Ipython blocks documentation. I will give you some pointers for what I did find, but it could be better. So we just do a dir. We make a grid object, and we do a dir on it like we love to do in Python, and we can see we've got height and shape and show image and a bunch of stuff that you might nothing in here is too surprising. But there's a toText method. So what's that all about? So let's just get a grid, and see what we get. And so it just creates this text object, row, column, and the red, green, blue values. And this can be used. Unfortunately, there isn't a build a grid from this text object yet, but I did find a program that I think will do it to build a grid from this text thing in about 3 lines of code. But I didn't have time to do that or test it, so that's why I'm not showing that. Another attribute I found was the lines on attribute. So when we turn the lines on equals false, these little lines go away. So if that's what you want, that's what they're there for. Okay, now let's look at the attributes of block. So I did the grid. I assigned block 0 variable to one of the blocks, and we'll do a dir on that. And you can see these attributes are different. There's blue, there's red, green, blue, there's column, there's row, there's a set colors method, a show, and a size. So when we show it, it just shows us the block. When we ask for the size, it's 25. These sizes are all in pixels. And when we show RGB, we get a tuple of the RGB values. And if we set the color to green and show it again, it's turned green. And then the kind of interesting thing is that then when we show the grid that we took it out of again, the cell has turned green. So even though we broke the cell out, it is still associated with that grid somehow. Now, unlike high school geometry, 0, 0 is up in the upper left-hand corner. Numbers increase to the left and to down, which is very common in graphics programming. There is another Ipython Blocks object called image grid that is useful if you have a lot of PIL code you want to use with this, but I'm not going into that. And that the origin is a you can change the origin on that one, but that's not for tonight. So one of the cool things about, so I just set some blocks, 0, 0, I set to red, 1, 2, I set to green, and 2, 3, I set to cyan, and showing the grid. So you can see how to do that. Now, when we get to real power of this is that you can use Numpy array notation, which is pretty much like Python list notation. But since the grid is a two-dimensional thing, it takes 1 or 2 parameters for the slicey thing. So if it only has 1, it does rows. So here I've just got 1:2 set to a color. It's setting row 1 all the way up, but not including row 2 to that color. And if there's a second parameter, it's going to be columns. So here I'm grid 0:2, comma, it will gives you the rows 0 and 1, and the 1:-1 gives you column 1 to everything until the last item. So you can graphically learn this slice notation, which always confuses me. I always have to go look it up. Last one, 0: means all the rows, and 2: means all the columns starting at column 2. So I think one of the powerful things is this copy thing. So I drew a grid with some colors so we could see what we're doing. And they also have a notion of a subvariable. So I just assign variable C to this grid, and it basically is taking this corner of 9 squares. And when we show it, we see that's what we get. And then we can copy it back into the initial grid with, by just assigning an area in the initial grid to C. Now, the only caveat is that the areas, the height and width have to match between both areas. Or you can just copy stuff from one part of the grid to another. You don't have to use this intermediate variable. Okay, the last thing I'm going to show you, go with the real notebook. It's a little hokey, but it really is animation. And the secret is there's a clear output command. And so that just clears the screen, and then we change it. We change which block is the green one, make the old one the black one, clear the output, and show the screen again. And this is where I think kids could have fun in it. So for more information, my GitHub, Tuite, has this notebook and the slides made for the notebook. There is the Ipython Blocks org webpage, which has a moderate amount of cool stuff. And then I found this other, it's kind of like a, if you wanted to do a class for 6th graders using Python Notebook, it has a lot of exercises and stuff in it. So that's it. Any questions? Oh, one last thing. Who here is interested in more talks about Jupyter Notebook topics? Okay, about half the people. Okay. And the ones who didn't raise your hand, that means you're experts and willing to give it time. Okay, questions?
You try to push it to like what kind of refresh rate and get how big it?
No, not everybody can see the code, but I had to import time, and there's a time sleep half a second command. So if I shorten that, it would go a little faster. But since it's Ipython notebook working on the browser, presumably in JavaScript somehow, I don't think it's going to ever get super fast. Yes?
You can still make out with slow 80s faster graphics speed.
Yes, you can. Yeah. That was another thing I wanted to do, but didn't have time to do.
How big of a grid have you made?
What?
How big of a grid?
You can make a grid that's 1 pixel, so you can have whatever will fit on the screen. And I've seen, and if you use some image libraries, you can import pictures onto the grid and then do weird stuff with that. And that's actually in ipythonblocks.org. There's an example of importing images. So if you're willing to have 1 pixel blocks, you can have pretty big grids.
I'd be excited not to write JavaScript, but I don't know if people want like 1 frame per second. Like,
yeah. I think if you wanted to do something with Python and graphics, you'd probably use Qt or something.
Qt is great.
Yeah. Yes?
Curious as to whether Ipython blocks was written mainly for teaching, or do people use it for graphics or any other use?
I think it was primarily written for teaching, but I'm not really sure.
Well, okay, so I don't know the entire history, but I got some of my friends that work up in Berkeley on this stuff. But basically, I think that, like she was saying, there's different kinds of blocks. You have these documentation blocks, you have these code blocks.
That's Ipython Notebook.
That's
Jupyter Notebook, not Ipython Blocks.
Oh, so wait, these things have a non-Jupyter representation that would pop up like a Tkinter window or something?
I don't know if this has been ported anywhere other than Jupyter Notebook.
Oh, they can export an image.
But you can export. You can export.
Oh, I think that's sense. Yeah. I mean, it's just like a way that you can kind of showcase colors and do other like sorts of things.
You can show bar graphs.
Yeah, you can do bar graphs.
There's on the website that's practicing.
Yeah.
Practicing Python. Okay. Cool. Mystery solved. All right. Good job, Vicky.
Thank you.